Okay, in this situation, we have Tarazan, and Tarazan is 30 meters above the ground, and he's going to swing down to the ground. So we're going to neglect friction and air resistance. So we can say, okay, Ki plus Pi plus work equals Kf plus Pf. All right. Well, initially it says Tarazan is at rest up there, so the kinetic energy is 0. The potential energy, we don't know it right now, but we can find it, plus work. Well, they took the time to say, okay, neglect friction, neglect air resistance. They're not talking about any other work, no jetpack on Tarazan, nothing like that. So the work would actually be 0. So we can get rid of that too. Equals kinetic final is what we're looking for, because they're asking how fast is he going to be going. So if we're interested in that, we're interested in the kinetic final. And if he's down on the ground at the end, the potential final's gone. So if we can just go find this initial potential energy, we're going to know our kinetic final. How do we do that? Potential energy is equal to mass times gravity times height. So potential energy is, they gave us in the problem, the mass is 60 kilograms. Okay. Gravity, we're on Earth. I assume, it's Tarazan. I'm not saying they can't have Tarazan on Mars. I'm not discriminating against Martians. I'm just saying. We end up with that big old number. Okay, so now there is our potential. So that's also actually our kinetic by the time it gets to the ground. How fast is he going? Well, in order to do that, we're always going to have to come back to the equation that relates kinetic energy to the velocity. So the kinetic is 17640 equals, our mass was 60, v squared divided by 2. So let's see, I'm going to do 60 divided by 2 is 30. Okay. And I'm just going to divide. So I'm taking 17640 divided by 30. And we get, running out of room here, let me, some space here. Okay, so we get 588 equals v squared, and we want to take the square root of the other side. So 588 equals v. Okay, so 24.2. Tarazan is bombing. Very nice. Solid, done.